Hi, it's Mike Nelson, and it's Wednesday. It's time for Weather Wednesday, and we are in the middle part of May now, so we are right in the midst of the beginning of severe weather season here in Colorado. Certainly, other parts of the country have had plenty of severe weather in recent weeks and months, but our mean season is just coming up now here, especially from Denver across the eastern plains. We'll start to see some of these scenes of those monstrous looking clouds, the hail, the lightning. Matter of fact, I think we'll get some pretty active weather coming up Thursday, Friday of this week. And so let's talk about it. This is severe weather season, and it's time for everybody to be weather ready, to know where you should go to get your warnings, what you should do when there is severe weather in the area, and especially for the kids out there, how not to panic or to get too nervous about it when we have strong thunderstorms around the area. So as far as our weather conditions, it's been a unique time because we're not in the studio anymore. I'm in my basement in southeast Aurora. Lisa's doing her weather from home, Katie and Stacy doing as well. So you might think that we're at a disadvantage to not have all the tools, but surprisingly, with technology, we're in very, very good shape. We can do a lot of the same things from home that the weather team was able to do in the studio. Sometimes we go a little bit crazy, but in general, I have all of my gear right here. I can look at all the maps, I can analyze the local surface conditions, and really give you a very accurate forecast, which frankly, we couldn't do this maybe 5 or 10 years ago, but with modern technology, even though we're not in the studio, we can do all of the same work that we could do before. Now, I want to give you just a few good weather resources that you should really look to have as you're heading into severe weather season. Storm Shield, of course, that's our wonderful weather app right there on your phone. And the beauty of Storm Shield is that it knows where you are by the geolocation on your smartphone. So when you have a tornado warning and you're inside that little box that's for the tornado warning, your phone goes off. Weather radios, of course, are great tools. I have one of them right here. My Midland weather radio. I highly recommend everybody have a weather radio. Gives you the forecast anytime just by listening. Gives you the weather, the warnings. Get a Midland weather radio, and you can search that online and get one of those. The difference is that a Midland radio will give you for the entire county. I'll talk about this a little bit more. Like Weld County, get a tornado warning, it'll go off for all of Weld County. But it's very, very valuable and great if there's a power outage or anything else. That's a weather service product that will give you wonderful information. Radar Scope is one of my favorite apps. It gives you the raw output from the Doppler radars around the country. It's a little pricey. I think it's maybe $30 a year or something like that. But if you're kind of a weather nut, look up Radar Scope. Really good stuff. Weather Tap, I use that one on my computers all the time for radar information as well. That's a good one to check out. And Weather Call, which you can get very accurate weather warnings delivered to any type of phone. Even if, say, your grandparents have an old dial-up phone or something, they can get a call on Weather Call. So I highly recommend Weather Call. Another one that's a really good source of information on a daily basis is the Storm Prediction Center, spc.noaa.gov, and highly recommend checking the Storm Prediction Center forecast every single day to give you kind of an idea of the areas that might get severe weather. All right, this slide's a little hard to read, and I apologize that, but in the pink, if you're the Denver, Boulder area, Greeley, Fort Collins, out toward Fort Morgan, all the way up to the northeast corner, your local weather forecast office is the Denver Boulder office. Western Colorado, from Eagle County all the way out to Utah, that's the National Weather Service office in Grand Junction. The Pueblo office is Teller County, El Paso County, up into Lake and Fremont County, all the way down across southeastern Colorado. That would be your Pueblo office. And for our friends in Yuma, Kit Carson, and Cheyenne counties on the eastern plains, they actually get their forecasts and warnings out of the Goodland, Kansas National Weather Service office. We've covered this in the past, but I want to go over it a little bit again. Our main weather makers for storms in Colorado, especially getting from the winter into the spring season, still continue to be these three main areas. We get low pressure systems that come out of Alberta, Canada, call those an Alberta Clipper. The Colorado Hooker or the Albuquerque Low, the Panhandle Hooker, that's that big low pressure system, the big red L that parks itself down over southeastern Colorado, draws in a lot of moisture from the Gulf of Mexico, combines with an upper air disturbance, so you can get some pretty good heavy rain and snow events, but also can be a severe weather maker as we get into the warmer season. And the fronts that come in off the west coast, which sometimes will push in, bring moisture, stall out for a bit, and bring us some stormy weather conditions. And the main thing in Colorado is the mountains. That 14,000-foot wall out there really changes the way things move and work. Rising air tends to lose its moisture in the form of rain or snow. Sinking air tends to warm up and dry out. And this is a major impact in how weather conditions form across the state of Colorado. I want to quickly touch on El Nino and La Nina because there has been some talk about the weather pattern shifting a bit. The El Nino pattern is very warm surface waters in the Pacific Ocean. Tends to create a lot of thunderstorm activity, puts a lot of energy into the atmosphere, and changes the way the jet stream flows, not only the Pacific, but across North America as well. Typically, it's mostly manifest in the winter time, but it does have some impact on our summer monsoon. When you get an El Nino pattern, you tend to get a jet stream flow that comes in a little more across the southwest, oftentimes a split flow that'll block colder air up into Canada. It can bring more moisture into the southwestern United States, increasing the summer monsoon, which kicks in July and August and tends to bring us a lot of heavy thunderstorm events at that time of the year. Now, the opposite is the La Nina pattern, and that's when the water in the Pacific is cooler, changes the position of thunderstorms near the equator, changes the effect of the jet stream pattern, and tends to favor more of a northwesterly jet stream flow. Favors our ski areas over central and northern Colorado in the wintertime, but also it can have a detrimental impact on the summer monsoon. And that's what we're starting to favor a little bit this year, unfortunately, which might kick back the amount of moisture we're going to see for our summer monsoon. We're already starting to see some drier weather conditions in Colorado right now, and drought beginning to increase again across the state. And if we continue to favor cooler sea surface temperatures in the Pacific and develop this La Nina pattern, that does not bode really well to get a good wet summer as far as the monsoon is concerned. So this is the latest 3-month outlook from the National Climate Prediction Center, and that's calling for hotter weather over the west, including most of Colorado with the exception of the extreme northeast part of the state. This does not look good for southwestern sections of the country. It's already been extremely hot early this season in Arizona, and looking like much of the west will be hot and dry. Colorado might just be in a slightly above average precipitation from Denver to the north and east, and much of the Midwest is looking to have a wet summer and a cooler summer, most likely across Minnesota, the Dakotas, into Iowa and Missouri. We're right on the edge of that, but I'm a little uncomfortable with some of this dryness we're seeing trends of indicated for southwestern Colorado especially. But we're kind of in between patterns now. This is one of my favorite t-shirts, given to me by a friend of mine named Tony Laubach. You'll see Tony's picture a little bit later. It says, well, it seemed like a good forecast at the time. And when we're in between patterns, sometimes you're not quite sure where things will go. We'll keep an eye on that. Okay, so we talked earlier about mountains create the weather in Colorado. So very often we can have cold, dense air that pools in the low areas and the valleys. Up on the mountains, you'll be windy and not nearly as cold. On the eastern plains, you can get down-sloping winds that come in, and we'll have warmer air, drier conditions in Denver. So we just saw this yesterday, where it stayed very cool out in some of the valleys on the eastern plains of Colorado because they had low stratus and fog. Stayed in the 40s and 50s. The areas that broke some sun, a little higher terrain, were much warmer. And it makes it tricky, certainly, to forecast in Colorado. Where are we in Colorado? Well, different locations. The old real estate Brome, location, location, location. Denver area, the Front Range and adjacent foothills extend from central Larimer County down into Boulder County, western Jefferson County, parts of Douglas County, down into Teller County, down around the Pikes Peak area. We are just to the east of the Front Range, but we oftentimes just call that the I-25 corridor or the Denver Basin here in the Denver area. Northeast Plains extending the lower terrain out toward a little bit north of Lyman, Akron, Yuma, out in that area, Fort Morgan. Cheyenne Ridge is slightly higher. If you drive up on I-25, you will go up some hills as you get up there toward Cheyenne. That's why they have all the wind farms up there. It favors a lot more wind generation there. And it's a west to east ridge that's a little bit higher. Again, air flowing uphill tends to lose its moisture, downhill tends to drop its moisture, air flowing downhill tends to dry out and warm up. So the same thing here, Palmer Divide, west to east ridge. You go over Monument Hill. That creates a lot of different wind patterns and weather conditions. Southeast Plains, down toward Lamar, La Junta. Another west to east ridge, the Raton Ridge, you head down, heading over into New Mexico, you go up and over that down near Trinidad. Sangre de Cristo Mountains here, and the Wet Mountains are there. San Luis Valley, Sand Dunes Monument right here. You know why the sand dunes are there? Wind coming off of the mountains to the west picks up dirt and sand, then it drops it down. It comes into the San Luis Valley. As it's going to go back over the Sangres, it drops that sand just right in here on this side of the Sangre de Cristo Mountains because it didn't want to carry the sand up over the mountains. That's why those amazing sand dunes there. Southwest Mountains, La Garita Mountains down here. Grand Mesa, which would be, if it wasn't a flat top, it'd be the highest mountain in the Colorado area, but it is eroded down to a big flat top. Western Slope, Northern Mountains, Central Mountains. Okay, those are our geographic locations. You want this picture? Send me an email at mike.nelson@denverchannel.com. I can send you that map so you know where you are. Here's a really good example of what happens with this terrain, all right? Snow in the mountains, dry on the plains, but look at the snow here that's fallen along the Palmer Divide. What would have happened in this particular case? We would have had a storm system that brought northerly winds in like this, north to northeast winds, and this area kind of forms a bowl right here of lower terrain higher to the west. Drop the snow in the mountains, drop the snow down along the Palmer Divide. Happens a lot. That's why we get heavier snows on the south side, the west side of the Denver area, and very often get snow on the Palmer Divide where you don't see it farther to the north. But the Palmer Divide also does something else in the warm season. That's called the Denver Cyclone. Be a great name for a sports team, but it's actually a weather phenomenon. When we get southeasterly surface winds going over the Palmer Divide, they rise up over the divide, they come down into the Denver Basin, and they tend to curve a little bit back toward the west. So we get a southeasterly wind, even an easterly surface wind. If you get thunderstorms forming over the mountains, they can produce an outflow of moist winds coming from the west, and they collide right here, forming a convergence line that runs from around Castle Rock through Aurora up toward DIA. And right along that convergence line, we very often will get thunderstorms that form and tornadoes that can form right along what we call the Denver cyclone or the convergence zone. So you might, if you read the forecast summaries from the Weather Service, you might hear them talk about the Denver cyclone setting up, and that is very often a time that we'll get thunderstorm activity that can produce tornadoes. Now, we can get tornadoes up in the mountains, but only about 10% of our tornadoes occur east or west, of I-25. Only about 10% in the mountains and foothills. The rough terrain up there tends to break up the circulations that we need to help form a tornado. But we get 90% of our tornadoes, and our biggest ones occur along and east of I-25, and oftentimes partly due to the effect of the Denver cyclone. This graphic's also a little hard to see, but I apologize for that. This is just a mapping of tornadoes in Colorado over the course of about 50 years, and almost all of them really are along and east of the divide. I mean, Washington County, Adams County, Weld County, by far the most tornadoes. Matter of fact, Weld County has more tornadoes than any other county in the United States. Now, most of them are not big tornadoes. There are some, such as the Windsor Tornado. We'll talk about that more later. But of all the counties, even we're talking counties in Texas and Oklahoma and Kansas, no other single county gets more tornadoes than Weld County does. Congratulations to our friends up in Weld County. But because of the rugged terrain off the west, relatively few tornadoes occur in the mountains, almost all of them along and east of I-25. Tornado Alley across the country. This really is, although tornadoes can occur anywhere in the world, The prime spot is the central part of the United States. And the main reason why is we have the mountains, the Rockies to the west, and we have the Appalachians to the east. We have a long, flat plain from way up in northern Canada all the way down to the Gulf of Mexico. So what that allows is cool, dry air from Canada to easily move southward, warm, moist air from the Gulf of Mexico to easily flow northward. Boom, they meet right there in the central part of the country, southern Minnesota, Iowa, Nebraska, Kansas, down into Oklahoma, Texas, and eastern Colorado, because that's where these air masses tend to collide. But the key thing is this warm, dry air that comes off of the plateau down to the south of us in Arizona and New Mexico. That's up there a little higher, say 7,000 to about 15,000 feet. So we very often will get warm, dry air that comes in and sort of sits on top of these surface air masses, forming what we call a cap in the atmosphere. So if you think about, let's say we have a little weather front between cool, dry air to the north and warm, moist air to the south, and it's sitting right there over eastern Colorado and across Kansas. During the morning, the sun begins to warm up the atmosphere a little bit, and we get the shoving match going on between the two air masses, bubbling up some thunderstorm activity. Now, if we didn't have this cap of warmer air aloft, what would happen is those storms would just start to develop by mid to late morning, and you get cloud cover and you'd get moderate thunderstorms and cut off the heating, and that'd be pretty much it for the day. But when we have this warmer air aloft, what that does is almost like, the analogy would be if you uncapped a bottle of soda pop, put your thumb over the top and shook it, okay? That foam is waiting to go, and when you take off the cap, your thumb, that stuff just erupts very quickly. So what happens is when the atmosphere is capped, we get all this energy that's building down at the lower levels during the morning into the afternoon, but it can't break through the cap. It's not quite strong enough to do that. And finally, by early to mid-afternoon, the cap breaks. You'll hear storm chasers talk about that. Even talked about in the old movie Twister. When that cap breaks, suddenly, whoosh, this rapid and explosive and violent development of thunderstorms, and that's when you get the really mean ones that cause severe thunderstorms and tornadoes. So, looking at the average number of tornadoes, we get about 50 here in Colorado, and again, 9 out of 10 occur east of I-25. Texas, Oklahoma, Kansas, Nebraska, Iowa, that's the big storm center. A lot fewer off to the other side of the Rocky Mountains, and they do get a fair amount in the eastern part of the country, especially in the late winter, Georgia, the Carolinas, etc. But we are really right on the western edge of Tornado Alley here in Colorado. Let's talk about warnings and watches. When a watch is issued, what that means is the Storm Prediction Center, I showed you that website earlier, has identified an area that is especially prone to get thunderstorm activity that could be severe during the next several hours. So we'll issue a watch for a large area, say eastern Colorado, and it'll be a period of maybe 5 to 7 hours, we'll say, during this time. There's a likelihood of severe thunderstorms and possibly tornadoes. Severe thunderstorm watch is generally more likely to be severe thunderstorms with hail, damaging winds. Tornado watch is a more serious thing because those storms are strong enough to possibly produce tornadoes. So watch means be prepared. Just be watching out. Make sure you've got your storm shield going. Make sure you got your weather radio ready. Keep an eye on Denver 7's website. Watch us on TV. When a warning is issued, that means your local forecast office, the Denver Boulder office, the Goodland office, the Pueblo office, depending upon what part of the state you live in, has identified an area that is either producing a tornado or a thunderstorm that could produce a tornado. Then it's time to take action and to go to your place of shelter. Storm clouds are certainly beautiful. Look at this great shot here of that thunderstorm off into the distance, but extremely dangerous. This is the view of the Simla tornado 5 years ago in June. Now this one did what I like to call natural crop rotation because it stayed out pretty much over open country and just spun the crops and the dirt around. But we can, of course, get tornadoes that form in metropolitan areas. As the metropolitan areas grow in Colorado, it becomes a bigger and bigger threat. You can see the beautiful structure on this. You can see it from a good distance away. Storm chasers love to chase in Colorado because we have flat terrain on the eastern plains, good road system, and very scenic, beautiful storms. But they can also be dangerous. We're coming up on the 12th anniversary of the very damaging Windsor tornado. This is the storm approaching the Windsor area at 11:30 in the morning. Lisa Hidalgo was doing the weather at that time and actually had the warnings on the air very, very quickly, but it's unusual for us to have severe thunderstorms that produce tornadoes this early in the day here on the high plains. We need to kind of wait later in the afternoon because we don't have as much humidity in the air. The temperatures at night tend to get a little cooler. So this was unusual for the time of day, for the strength of the tornado, and the fact that it moved toward the northwest. It actually went from the southeast toward the northwest. You can see the damage, caused one fatality as well, and certainly every year, 22nd of May, the folks in Windsor are very wary of the potential for those types of storms. Most of our damaging tornadoes are called supercell tornadoes. They form from large rotating thunderstorms, and they can produce what we call a hook echo. And that's where the tornado would be right there. It looks like on the edge of the fishing hook. And on Doppler radar, we can actually see the rotation. What Doppler radar does is it not only can see the rain and the hail, it can see how it's moving inside of a thunderstorm. So we can see areas of rotation on a Doppler scan. And that's what meteorologists, when we look at what we call our velocity scan, we're looking for this little couplet where red and green indicate the shearing, the motion of the rain and the hail inside the storm. I talked a little bit about storm-based warnings. Weld County is a huge county, so is Larimer County. So if we issue a tornado warning for Weld County, you're going to be issuing a warning for an awful lot of people and an awful lot of square miles, when in fact the warning area is much, much smaller. So in case of the Windsor storm, it was just this little box or polygon that was where the warning is issued. That's where Storm Shield comes in so handy, because it just issues the warning for that little polygon instead of warning the entire county. If you're not in the warning, you don't get a warning message on Storm Shield. So key thing on that, again, here I am on TV a few years ago, tornado that touched down out near Watkins, and that's the hook echo, again, right there, very clear to see. The Storm Shield warning will only call you and give you that warning if you're inside of that polygon. It's a free app. You must get Storm Shield if you don't have it already. All right, now we get another type of tornado here in Colorado, and they happen a lot. And those are land spouts and gustnadoes. These are non-supercell tornadoes, so they're not forming from a giant rotating thunderstorm. They're actually caused by swirling winds at the surface that kind of get drawn up into the updraft of a developing thunderstorm. They're generally quite weak. I'll go through some of the enhanced Fujita scale for you in just a bit, but they could move your lawn furniture around and could cause some damage. We might issue a warning on these. Very often we'll just come on and say with an advisory there might be some weak, short-lived tornadoes that form. But nonetheless, technically, they're a rotating column of air from a thunderstorm, so they are technically tornadoes. Here's why they happen a lot. This is a radar scan. Denver's right here. Fort Collins, Greeley up here, Fort Morgan out here. We get a lot of spotty little thunderstorms. They pop up, they last an hour or less, and they die away. It's partly because in the high plains we don't have a lot of surface humidity to form huge squall lines of thunderstorms, so you get little spots that develop. And when these develop and go through their life cycle, when they're dying away, they put out a cool, moist outflow from the bottom of the thunderstorm that flows out in all directions. And so if you have a band of storms to the south of Denver, a band of storms to the north of Denver, these outflow boundaries of cool, moist air will actually move toward each other and form a new area of showers and thunderstorms. That's why if you get something good like radar scope on your phone, you can actually see these outflow boundaries, because the Doppler radar is so good, it can pick up these moist little boundaries. Sometimes it's showers, sometimes it's actually insects blowing around that the Doppler can see, and we can pick up where these boundaries are. When they collide, you can get thunderstorms form. You can also get weak, short-lived tornadoes, because if you think of these two boundaries coming together, they hit. If there's any rotation in that boundary, as it gets drawn up into a new thunderstorm, that starts to spin. You can get these little short-lived tornadoes that form that look kind of like this. Colliding boundaries come in, and you can see the difference here. There's no big wall cloud or parent thunderstorm up here, and it's actually wider at the bottom than it is at the top, because as these colliding boundaries come in, it's drawn in like this, and it goes up to the top. Technically a tornado, might issue a warning on it, but it's not going to be anything that would be like the Windsor tornado back in 2008. So a land-spout tornado or a gustnado is a weak, short-lived, non-supercell tornado. Nonetheless, we see them all the time, and they're worth at least keeping an eye on, and you might even get a warning on them. Now, stronger ones, we had our tornado that hit out in Southlands. I live down in Heritage Eagle Bend, which is very close to Southlands in southeast Aurora. That occurred on June 7, 2009. That tornado tore some things up pretty good, and it was a storm that was certainly dangerous. This, I showed you earlier, this is a picture of the Lake George tornado, June 8, 2014. Weak tornado, non-supercell, formed up in the mountains, which is rare, but again, about 1/10, 9 out of 10 tornadoes occur east of I-25. That means 1 out of 10 occur on the west side of I-25. So let's go through the scales. Your EF0 and EF1 tornadoes are weak. The wind speeds anywhere from around 85 to about 100 miles per hour. We get a lot of these because we get that would be your land spouts, are the EF0s, EF1s, and we'll warn on them and say they're pretty weak. Now, start to get a little stronger by the time you get up to the EF2s. These are starting to be fairly strong tornadoes. Wind speeds of 111 to 135 miles per hour. They'll tear roofs off. They'll pretty much trash up the trees, knock down power lines. We get a fair amount of these every year, probably a dozen or more across Colorado. When you get to the EF3, that was the Windsor tornado. And that one had wind speeds of about 165 miles per hour. They will certainly destroy buildings and cars, cause a lot of damage. We don't get a lot of the next ones, the 4s and 5s, and frankly, that's okay, because those are the really, really damaging ones. Those occur more to the east of us where there's higher humidity, more energy for the storms to get really, really big. We can get them, but they generally occur farther east on the plains, out in fairly open country closer to Kansas, Nebraska, and these have winds up to around 200 miles per hour for an EF4, and then of course the 5, the finger of God from the movie Twister, wind speeds of 200 miles per hour and above. An extreme tornado. We don't sometimes go through the whole year in the United States and not get an EF5 tornado, but generally this is going to be Oklahoma, Texas, down into the southeastern part of the United States to get an EF5. These can be 2 miles wide at the base. These are definitely extreme storm systems. By the way, the EF, in the old days, it used to just be the Fujita scale, which was named after Dr. Ted Fujita from the University of Chicago, based upon the wind damage that he saw from what the storm would do. In recent years, they enhanced it. That's why it's called the Enhanced Fujita Scale, because the changes in the structure from a brick to a frame building made a difference in the damage. So that's why you hear the EF5, but older tornadoes would have just been categorized as an F5 or one of the other numbers. All right, look at this thing. This is a mothership, a rotating supercell. That whole cloud is spinning as surface winds come in from one direction, interact with the jet stream from another direction, get the whole thing spinning. Ominous, looks like something out of a Steven Spielberg movie. These can produce large hail and damaging tornadoes. And they come in different flavors. There's an LP supercell, which means low precipitation supercell. Very dramatic looking pictures. Not necessarily a lot of precipitation, and so storm chasers love to chase these because they are ominous and they are magnificent in their scale and their size, and they're spinning some beautiful pictures. But they also, because they have little precipitation, they give you a chance to get out of there and safely get away. This is an HP supercell, high precipitation supercell. This area over here, that is large hail, extremely heavy rain, and very dangerous places to be. These are dangerous to chase because you can't see where the tornado is. And also the roads will get completely flooded out. You'll get large damaging hail. HP supercells are the bear's cage when they talk about that again in the movie Twister. And they can produce large hail and tornadoes. The key thing if you're going to chase, and I'm going to talk about that more, make sure that you know the roads. This is a mud road out here. If you are driving on that and you get heavy rain, that turns into goo, okay? This is dirt now. It turns into wet, heavy clay. You get your car stuck. You can't get out of there. Very dangerous. So make sure your road system, when you're chasing, you know what you're doing. We'll talk more about chasing in just a bit. This is a beautiful supercell Look at that thing. It looks like it's something from Independence Day settling in over Julesburg, Colorado. Taken from our Viero camera network a couple of years ago, and you really see the cool structure of that particular storm. But I want to talk to you about this. Tim Samaras was a friend of mine. Tim Samaras was one of the greatest storm chasers who ever lived. His son Paul and their chase partner Carl were killed in the El Reno tornado back in 2013 down in Oklahoma. This guy was the best in the business, folks, as far as knowing how to chase and chase safely. And he ended up, along with his son and good friend, dying in a tornado. Unless you know what you're doing and have taken classes on how to safely chase, please do not chase. Leave it to the pros. This is my friend Tony Laubach, and Tony chased very often with Tim. Tony has seen now somewhere on the high side of 450 tornadoes. He knows what to do. He knows how to safely get in and get away. But even with that, chasing tornadoes is a bit like being an astronaut. It is fundamentally dangerous to strap yourself to a rocket and get shot into space. It's fundamentally dangerous to chase tornadoes. Lightning, large hail, flash floods, and the tornadoes, these are all risks that you can face. These guys know what they're doing, but even the best of the best ended up being killed by a tornado. So please don't chase unless you really understand the hazards. Speaking of hazards, let's talk about lightning. Beautiful, dangerous, but a major hazard here in Colorado. Look at this great shot over the Denver skyline. And one quick thing, there is lightning, which is Lightning, and there's lightening, which is like, I have understanding from on high. So when you're talking about lightning, this is lightning, that would be lightening. Just throw that out there. Remember, it takes the sound of the thunder about 5 seconds to travel 1 mile. So especially boys and girls, if you're outside playing and you can hear thunder, it's close enough that you should go inside, because generally anything 3 miles in you can hear. But if you are outside and you want to know how far away a storm is, when you see the flash, start to count slowly till you hear the thunder. Flash. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thunder. That would mean it's 2 miles away, because it took it 10 seconds to travel that amount, so 5 seconds per mile. So you can do this simple math equation and figure out how far away the storm is, or if the storm is moving closer to you, because if the amount of time between the flash and the bang is getting smaller, storm's moving in. If it's getting farther apart, storm is moving away from you. And you know, we love to be outside. We're fishing, we're golfing, we're sailing, we're swimming, and most of the lightning fatalities occur from outdoor recreation and large bodies of water, golf courses. Our biggest time is June, July, and August. This is the biggest threat that we have along the high plains. Flash flooding is big, hail is big, tornadoes are big, but lightning is our biggest killer, so be very, very careful about that. Now, talking about hail, peak season for hail, May through July. Get our cars looking like moonscapes out there. If you see this off in the distance with a thunderstorm, that white, that's hail. And so whenever you see that off in the distance, you know that storm is dropping hail. Could be large hail, as a matter of fact. Our worst time for that is really getting into July and August. And we've seen these kind of pictures, the amount of damage. The greatest insurance losses are caused by hailstorms in the Denver area and across all of the Front Range. Part of that is because we're a little higher, so we're close to the cold air aloft. Our thunderstorms produce hail. That hail doesn't melt before it gets down to the ground, and we get a lot of hail here along the eastern flanks of the Rocky Mountains. Another thunderstorm threat, straight line winds. When that thunderstorm drops its rain, cool, dry air comes down, hits the ground, fans out in all directions. So a downburst or a microburst is a non-rotating wind that's created when a column of sinking air in a thunderstorm hits the ground, spreads out in all directions. We can get gusts up above 100 miles per hour. The microburst certainly causes a lot of damage that we have here along the Front Range. Here's an example of it. You got moist air aloft, dry air near the ground. The cool air is heavy and drops rapidly down to the ground, fans out in all directions, and you get the strong winds. And let's not forget flash floods, a major hazard in the severe weather season. 12 inches of fast-moving water can carry away a small car. 6 inches of fast-moving water can knock a person over, and up to 18 to 24 inches of water can carry away an SUV, a van, or a truck. And when a vehicle is carried away in a flood, it doesn't float like a boat. Generally what happens is the front end is heavy because of the engine, so it goes over like this, then it flips over. Never, ever drive through an area that you do not know how deep the water is. This is an example of what we had from the flood back in September of 2013. That front range flood dropped as much as a year's worth of rain in about 4 or 5 days here across the front range, causing tremendous flooding and damage. Now, a couple of things you can participate in if you want to help us with our precipitation network. And one of them is CoCoRahs, that's CoCoRahs.org. You can become a volunteer weather observer. Go to CoCoRahs.org, great website. You can get a rain gauge, put it out there in your yard, keep track of the precipitation, report it each day on the CoCoRahs website. We have over 20,000 CoCoRahs volunteers worldwide that are reporting information. And you get a hail pad, which is this neat little piece of styrofoam that's covered in aluminum foil, and by seeing how big the dents are, you can see how big the hail was from a storm. CoCoRahs, great resource and a great thing for weather observers to be a part of. We like to observe the weather with our Viero camera network, and our friends at Viero Wireless that do a lot of the cell phone work all across the High Plains have cameras on their towers all across eastern Colorado, southeast Wyoming, western Kansas, Nebraska. So we have eyes on the sky in all the small towns and cities across the eastern plains. These are high-definition cameras. We can catch all kinds of weather, and it's an exclusive on Denver 7. We're the only ones that have these eyes on the skies in the Denver area. We'll talk about our atmosphere. You know that almost all the weather occurs down in the lowest 5 to 10 miles of the atmosphere, way down here. And by the time we get up to where the northern lights and spacecraft are, almost all of our weather is confined to a very small, shallow area of our atmosphere. And then it's just the cold blackness of outer space. And that atmosphere is changing, folks, because our climate is changing. When we burn gasoline in a car or coal in a power plant, part of what comes out of the smokestack is something called carbon dioxide. It's invisible. We breathe it in all the time. It's not poisonous, but it acts like a blanket over the planet. And what it's doing is trapping heat that would otherwise escape into outer space. What that means is the planet is gradually getting warmer. Doesn't mean we won't have winter. Winter's a season. Doesn't mean we won't have snow. Snow's a snowstorm. But the climate is gradually warming around the world. And as it does, it adds more energy into the atmospheric system, which can mean we'll have floods that'll be worse, droughts that'll be worse, the outbreaks of storms may be worse, although individual storms are necessarily hard to pinpoint just on climate change. But as the atmosphere gets warmer, things get weirder. And so that's why climate change is important. People will say to me, well, you know, you can't even forecast tomorrow's weather with 100% accuracy. I know, but climate is easier to predict than weather. Weather is chaotic. Climate is a long-term average. You'd expect Miami to be warmer in the winter than Denver, but the weather on a given day in Denver in the winter might be warmer than in Miami. Doesn't mean the climate's changed in Miami. That means that the weather had changed in Miami. So it's easier to predict climate than it is weather because it's basic thermodynamics. If you add heat to something, it gets warmer. That's why day is warmer than night and summer is warmer than winter. I'd say weather is what you get, but climate is what you expect. So weather is one play in a football game, while climate is the history of the National Football League. If it's snowing in Las Vegas during the winter, well, it is winter time. You would expect more unusual weather events as the climate system gets more energy. We're creating a steroid effect by warming up the planet, and that's going to make droughts more dry, floods more wet. Things will get more extreme as the climate gets warmer. And we know that it's not political. This is nothing about red politics, blue politics. It's just thermodynamics. Without the greenhouse effect on our planet, the planet Earth, the greenhouse effect is the gases of the atmosphere that trap the heat from escaping into outer space, which we're gradually making work a little bit better with more carbon dioxide. We'd be 60 degrees colder, and it would be just an ice planet here on Earth. So it's just too much of a good thing when we're adding this carbon dioxide. We can measure this in a lab. This is science that we've done for a long, long time, folks. Each doubling of carbon dioxide increases the energy retention in the atmosphere, this blanket, by about 3.7 watts per square meter, which is like a child's nightlight over every square meter of the planet, which is a huge amount of energy taken over the entire planet Earth. And so that's what's the deal. We're just adding more to this energy. And with that, the forcing from that addition of carbon dioxide is about 5 degrees Fahrenheit of warming over the entire surface of the Earth for a doubling of the CO2 from pre-industrial levels. And the melting of the ice caps and glaciers, Greenland, Antarctica, could cause the sea level to rise 5 to 10 feet in the next century. Again, that doesn't mean we won't have winter, because winter is a season. Weather will vary greatly. Great December blizzard of 1913, the Great March blizzard of 2003. We'll still see that in the cold season, but it does mean we're going to see more variety. This was along the Front Range. 2012, fire. 2013, flood. 2014, drought. And as I mentioned, we're tending to get toward drought again, it looks like right now, across Colorado. So anytime we get some moisture, be thankful for it as we get through this weather season. But I think we can do some things about it. We cannot take the carbon dioxide out of the atmosphere very easily. That will be up there for centuries. Maybe we'll figure out carbon sequestration somewhere down the line that would be on a meaningful scale, but we can increase our water storage, our water conservation, change the way we build roads so that when they're in flood-prone areas such as the Big Thompson Canyon, maybe they don't get blown out quite the same way. Modernize our forest and fire policies, improve our warnings, change zoning in threat areas, change our agricultural techniques, and make smart and effective regulations. These are the things that we can do. And we're trying to do this at Denver 7 too. We have solar panels on the building. I have solar panels on the roof of this house, solar panels at the radar site. I drive a electric car. So we're trying to do the things that we can to make meaningful changes going into the future. And we've done it before, folks. When people say it's too expensive to solve this problem, look at the problem we're in right now. We've done other very expensive projects in the past. The Transcontinental Railroad, water treatment, indoor plumbing, the Rural Electrification Project, the Manhattan Project, the Interstate Highway System, NASA, the Apollo program, fiber optics, the internet, high-speed computing. None of these bankrupted our country, and all of them made our world a better place to live. So we're going to finish up. Talked about weather, a little bit about climate. Our next moonshot for this country and this world is to figure out how to stop lighting carbon on fire and come up with better, more sustainable ways of powering our planet and our society to keep us all healthy. Because it's not just about polar bears, it's about our children and our grandchildren. Cute little guys, aren't they? That's Liam and Owen and Josephine and the rest of the fam right there. Hey, been great to be with you on Weather Wednesday. We're going to post all the Weather Wednesdays up on the Denver Channel Facebook page, and I'll put them on my Facebook page. I'll link them right up to the top. My Facebook page is Mike Nelson, Denver 7. We'll have, I think we've had 5 of them now, so I'll have links to every one of those so you can look through, share, comment, add questions, and again, if you want to get in touch with me, let's see if I can come back to that. Let me find it again here real quick. I'll put that back up at the top. Do I have it in there? No, I don't. Okay. Thought I had that slide. Anyway, if you want to get in touch with me, email is mike.nelson@thedenverchannel.com. Facebook is Mike Nelson, Denver 7, and Twitter is Mike Nelson 247. Been great to be with all of you guys again. We'll see you next week for Weather Wednesday. Everybody stay safe out there, and tune in. We'll be on the TV tonight, 4, 5, 6, and 10. Have a great afternoon, everybody.